Hey everyone, so in this video we are going to discuss about text classification. So I'm going to download a dataset from Kaggle. The dataset name is Spam SMS Spam collection dataset. There are 4-5 columns in this CSV file, but there are only 2 columns which are of interest to us, the column number V1 and V2. Okay, so the column number V1 represent the label and the V2 represent the text, SMS text. So the problem statement is, if you have some SMS text given, you need to predict whether this text is going to be a spam or ham. Okay, ham means relevant message, spam means messages which are not relevant, marketing message, other kind of messages which are not very relevant to the user. Okay, so that's the problem statement. You have label data in the form of training data, text along with its label, and then you are going to create some machine learning models, basically the classifier models, binary classifiers, and this model will predict whether a given text is a spam or ham. So I have downloaded the data and uploaded it into my Google Colab notebook. So this file is spam.csv, contains the dataset. Okay, now we are going to process it to build our text classification model. So let's load this dataset. Once we load this dataset, we find that there is some encoding issue in this spam.csv file. Okay, so to fix that encoding issue, basically when pandas read some CSV file, it uses a default encoding which is UTF-8, but this file has some characters which are not UTF-8 compatible. Okay, so we are going to try different encoding. Okay, we are going to try this encoding ISO 8859.1. Okay, and we found that this encoding is going to work. Okay, so now let's read our file again with this encoding instead of UTF-8. Okay, now you can see the column V1 and V2. So V2 is the SMS text and V1 is the labels. Now we will create a new SMS data frame from the raw data frame. The raw data frame was created using the CSV file. Okay, we are going to rename, we are going to pick V1 and V2 column from the existing data frame, raw data frame, rename V1 as label and V2 as SMS text. Now we are going to import all the relevant packages. Okay, so how we are going to solve this problem? First, we are going to convert these text into a numerical format. So we already know in NLP the technique term frequency inverse document frequency. Okay, so that is a function in Scikit-Learn which convert text into numerical format, and then that text, once converted into numerical format, can be consumed by some model for the training. Okay, I will give a link for this term frequency inverse document frequency concepts. Okay, if you don't know about it, you can go to that video and learn about it. Okay, it's a very simple concept. So we are going to convert all the SMS text into their frequency vectors. Okay, we are going to import all the classifiers which we are going to use. So we are going to try like 7-8 different classifiers, including naive Bayes, logistic regression, random forest, k-means, and others. Okay, so in this section I have imported all the relevant libraries which I need to use in this code. So as you can see, we have already created a SMS data frame with 2 columns in it. Column 1 is SMS text and the other column is label, ham or spam. Okay, so now we are going to assign X, that is feature value, and Y, that is target value, to X and Y variables. Then we are going to split this X and Y arrays into test and train split. We are going to use 80% data for training and 20% data for testing. Now let's convert the SMS text into the TFIDF vector. So that is very simple. You just need to create an object from TFIDF vectorizer class and then apply fit transform in the training data and only the transform on the test data. So this is the TFIDF vector for training. This is the TFIDF vector for testing. Now let's train the classifier, the naive based classifier. This is the naive based classifier. We have already imported it. As you can see here, Scikit-Learn naive base import multinomial naive base classifier. Okay. So we are going to train this classifier. So once the training is done, we are going to see the confusion matrix. Why confusion matrix is important? We need to actually identify how our classifier is behaving, how well it has been trained. Okay. So now once the training has been done, we are going to plot the confusion matrix and we'll see how many spam has been actually identified as spam, how many ham has been actually identified as ham. Okay, so you can see in the confusion matrix we are using confusion matrix function from Scikit-Learn library. We are providing the test database labels and the predictions label that our model has predicted, this model that we have trained here. Okay, now we are comparing them. You can see the in confusion matrix all hams are actually identified as ham here. There is no error in that, but there are a lot of spams which were actually spam which have not been identified as spam. So 108 spams have been correctly identified. This is the actual, this is the predicted. Okay, but there are 42 spams which have been identified predicted as ham. Okay, so that is wrong. So we can see the naive base accuracy is very good for the ham identification but not for spam identification. So what we are going to do next is first I am going to explain you the F1 scores, ROC AUC scores. Okay, because that is a very important concept in evaluating your classifier's accuracy. And once we are done explaining F1 scores, precision recall, ROC, ACU scores, etc., we are actually going to then try 7-8 different classifiers which are available in Scikit-Learn library, and we will see how the accuracy improves with them. Okay, I have already tested all those 7-8 classifiers. I'll show you how to create those classifiers in Scikit-Learn. It is very simple. You just need to here, like you have defined your classifier as a multinomial naive Bayes class. You can just change this one single line and you can keep on importing new classifiers classes from Scikit-Learn library. So it's very simple, just 1 or 2 line of changes, okay, in your whole code, and the rest of the code will remain same. Okay, so first let's focus on F1 score, ROC, ASU scores, and then we are going to see how to change the classifiers. So now we will discuss what is F1 score, what is ROC, ASU score. So first let me recap the theory of F1 and ROC scores, etc. I have another video where I have explained what is F1 scores, what is precision recall. I will put the link of that video in the description of this tutorial. Okay, but I will also give you a quick recap. In this notebook, which I am also going to share in the description of the video, in this notebook itself I have documented what is F1 scores, how to calculate it. Okay, so you just go through, either you can pause the video right now and just read these lines to understand what is F1 scores, what is ROC AC scores. Okay, in Scikit-Learn there are direct functions to calculate these things. If you know the your predictions label, Y predictions, and you know your test labels, like the labels which have been which are ground truth. Okay, so Y test and Y prediction, if you have these two labels information, you can directly calculate F1 scores, ROC, AC, AOC scores using the functions which are directly inbuilt in Scikit-Learn. So these F1 score function, ROC, AOC score function, all these functions are available in Scikit-Learn. You can see I have imported it here, so we need not to write it from the scratch. Okay, you can just import these functions, put y prediction, y test, and these scores will be calculated for you. So based on this theory, if F1 score is closer to 1, the model has good precision and recall. It means it is performing well at correctly identifying spam. Okay. Now ROC-AC scores, if it is close to 1, that is a perfect classifier. If it is closer to 1, it is a good classifier. If it is closer to 0.5, it is for a binary classifier, it is more or less like a random guessing. So in our naive based approach, the F1 score has been coming out as 0.83, and ROC-AC scores, let me check how much it is coming. It is taking more time. Okay, so F1 score has come as 0.83 and ROC-AUC score has come out as 0.97. Not a perfect one, but close to that. Okay, now this is how you can draw the ROC and AUC curve line. Okay, so you can see this graph. So I recommend you go through this text, okay, in the notebook, or you can pause the video, just read it here only, and you will understand what I mean by F1 score, space and recall. I'm not going to repeat it. What I'm going to do is I'm going to link a video where I have explained these things in detail. So as I have explained earlier, we were using naive based classifier. Now we can see what are the different classifiers available in Scikit-Learn library to do any kind of classification task. So I have listed down here all the different classifiers which are available. Okay, and I have ran it all these classifiers one by one. So I have got mixed results. Sometimes the accuracy has dropped, sometimes the accuracy has improved, sometimes the classifier itself took a lot of time for training. So I have added my comments here, like this k nearest neighbor classifier, it gave very poor results. These SVC classifier, it gave somewhat okay results. This MLP classifier, it took a lot of time for training. So the process is same, just like we have done the naive based classifier training. We call the fit function on the classifier object. The same thing we are going to do here. We are just going to change one line. We are going to keep on changing our classifiers initiation object. Okay, so in one case we have used naive based, here we are using logistic, like that. So what you can do is just go to this notebook file and just comment out any of the classifier and run it and see how it impacts the confusion matrix, how it impacts the F1 score and ROC scores. Okay, and you can refer to the text that I have put here for the explanation of what is F1 score, ROC scores. I am also going to put the link of video where I have explained these topics. Okay, so this is how the spam detection problem works. You have text, you have labels attached to those texts. The very first thing you do is you find somehow some way to convert that text into numerical format. So how we did it? If we recap, we used the TFIDF vectorizer. Okay, so this is actually a very good vectorizer, term frequency vectorizer, and it works pretty well in most of the basic cases, and even in real life datasets it works well. Okay, so you can just do the vectorization first. Once you have vectorizer, it means you have converted your feature variable from text to some kind of numerical format. And once you have converted your text into a numerical format, that point onwards classification problem becomes straightforward. You pick any classifier. Okay, you do the fitting of that classifier with your training data, and then you just check the predictions with the help of confusion matrix, F1 scores, ROC scores, and whatever classifier works best with your data, you use it for the future purpose. So that's how it's going to work. Now we are going to see how to use this trained classifier to do the prediction. Okay, so let's say you have been given a text, your free entry to a context is awaiting. Click here now. It looks like a spam SMS. Okay, let's see how our classifier predicted. So I'm going to run this code. Our classifier will do the predictions. Okay, it has predicted that the probability of this being ham, it means relevant message, is 0.01, while the probability of spam is 0.98. So we can see our classifier is able to predict the SMS text on the unseen message very accurately. So this is how you do the predictions. Once you train the classifier, you can use the same classifier to do the prediction.